All right, greetings from Antarctica. I got an email today from Emily and Holden at Cordova Middle School, and they wanted to know, if it's so cold in Antarctica, how come all the water doesn't freeze? That's a great question, so let's find out. All right, so we know, if you've been following my journey, that Antarctica is the coldest, windiest, driest, highest continent on the planet. Temperatures at McMurdo can drop to negative 59 degrees Fahrenheit. That is cold. So I think ice is cold. And you may know that ice freezes at 32 degrees Fahrenheit. So when you compare the coldest temperature ever recorded at McMurdo, minus 59 degrees Fahrenheit, to the temperature at which water freezes, 32 degrees Fahrenheit, and my thermometer won't even go down to minus 59, but that is over 90 degrees difference. So there's a 90-degree difference between the freezing point of water and the coldest temperature ever recorded at McMurdo. That just makes me cold thinking about it. So you ask a good question. Even though the temperatures can get so low, some of the water doesn't freeze, which is why Weddell seals can live here in the middle of winter. So let's talk about why the water doesn't freeze. We know that pure water freezes at 32 degrees Fahrenheit. So back in the States, this glass of tap water would freeze at approximately 32 degrees. But not all water is pure, meaning that sometimes water may have minerals or salts dissolved in it. And the water in and around the Ross Sea and the Southern Ocean that the Weddell seals swim in isn't pure water. It has something in it, salt, and a lot of salt. The salt does affect the temperature at which water freezes. So let's do an experiment. We have 3 cups here, all of them filled with water, and all of them have the same amount of water in them. The first one is labeled control. The second one is labeled 1½ teaspoons. And the third cup is labeled 3 teaspoons. So I've got my cup of salt here. We are going to add, we're not going to do anything with the control group. We are going to add 1½ teaspoons of salt to my second cup. That's 1. Here's my half. And then we will add 3 teaspoons of salt to my third cup. All right. Next, we're going to stir the water. I'll stir all of them, even the control group. There's the second one, and I'm stirring them so the salt fully dissolves in the water. And now to my third. Now what we're going to do is place all 3 cups of water in the freezer. So stay tuned. Okay, we're back, and our samples have been in the freezer for quite some time now. So let's take a look. Here's our control group, and we will try to, this one's kind of a tough one, try to get it out. And what I want you guys to say, or figure out, is if this is frozen solid, almost frozen, slushy, or not frozen. I don't know, I'm thinking this is pretty frozen solid. There's no water coming out of here. It is pretty frozen. Wouldn't you say? We'll go ahead and leave this in here. Now let's take our next cup, 1½ teaspoons. Ooh, this one's a little easier to come out. Let's take it out. Remember, we have to figure out if it's going to be frozen, solid, almost frozen, slushy, or not frozen. Uh-oh, look at this. There's some water. It's a little slushy. And the top part, it's kind of frozen, but it's actually fairly soft. And pieces and parts are flaking off. So I would say this was a little almost frozen, but it's kind of slushy too. And let's take our third one with 3 teaspoons. Whoa, this doesn't feel very firm at all on the bottom. Let's try and take this out. You can see this, but there's just a little bit on top that's frozen, but it's very soft. It feels like I could just break it. A lot more water here. That was a little slushy, and take a look at this. This is really falling off. So I would say this is basically slushy. All right, so from our experiment, you can see that the salt does affect how water freezes. All right, so in the first 2 cups with salt, we can actually see lines and channels that formed in the salt. Now I'll add a drop of food coloring to see them close, a little closer up. Try and do it on the side here as well. You see all those lines and channels? Now I want to know, how do these channels form? When water freezes, it forms tiny structures that look like crystals. And you've probably seen this if you've ever looked closely at a snowflake. When these tiny crystal structures form, they form out of nearly pure water. So when we look at the glaciers and the icebergs here in Antarctica, they form from nearly pure water, and the salt that gets left behind is in the unfrozen water. So when salt water freezes, the impurities in the water, such as the salt, are forced out or rejected, creating these tiny ice channels.